As India moves towards a $1 trillion digital economy, data centers have taken center stage, but it also comes with its opportunities and challenges. So to begin with, to set the context, data centers are the foundational pillars of technology today, but we are also facing some resistance globally, with power consumption being one of it. So, but we also need data centers at scale. So, are these, is this a love-hate relationship with the industry, with the companies? And adding to it, a quick intro of 20 seconds in what made you guys join the data center business years back.
Good afternoon, everybody. I know AI needs data, and which is artificial intelligence. Human intelligence needs food, and we are the only one who are keeping you away from your raw data, which is food. So let's just finish this panel fast. So yeah, the question is why I got into data center. It was way back in '99, so it's almost like 27 years back. But I was a young product manager who was enamored with internet at that time, which itself was a new thing at back then. I joined Reliance. I was among the first 3 or 4 employees of Mr. Mukesh Ambani when he started Reliance. And I always say very proudly that he was the one who actually, in one fine day at his head office of Reliance, told that you are a young guy, why do you want to follow the path of oldie guys who are building India's network, the fiber and all? Why don't you go into something which will become the future refinery of data, which is data centers? That's how I got introduced to data centers in Reliance. And after that, I just remained there. Nobody else gave me any other job. So for last 27 years, I'm just doing data centers. Thank you.
I've been a silicon guy, semiconductor person doing custom silicon for many use cases, and I've seen custom silicon wave from the original consumer, the internet, data, and then came cloud. And then we realized that cloud does not have a prefix of saying what silicon it needs, and then there's a lot of custom silicon came in, which became cloud and data center and AI, what you see right now.
Actually, I will see that I didn't choose data centers. Data centers just chose me, maybe. It's been a long time back. I also started in way back, if you guys remember the company called CMC in government, where I was in the systems team. And then I moved into something called high performance computing. So I realized that when people talk mostly about the fancy applications, I was more interested in what powers those applications, the big irons and how do you scale the applications. And has been my interest from that. And from HPC, I shifted to AI data centers.
AI data centers just happened, but what makes it interesting for me is that it's involved in converting raw energy, raw electricity, into intelligence as an output. In ancient times, the alchemists used to convert lead to gold. Now we are converting electricity to intelligence.
Okay. So can I say it's a love-hate relationship?
Okay, let me just answer it in a different way. See, I think as a society, you will always have a need for a balance between economic growth and the concerns for climate, right? Because any economic growth in any sector will always come at the expense of resources, right? And those resources will be like power, water, or any other natural resources, right? Whether they are consumed by machines or our buildings, or whether they are consumed by humans, but any growth will come. Or for example, when we are going for roads, bridges, hospitals, schools, metros, everything, is ultimately consuming resources. You cut trees also because you have to have economic growth in urban areas, so there will always be a balance. In context of data centers and AI, of course, because data centers are power guzzlers, with AI coming in, you are talking about GPUs and these high processing machines. So naturally, this concern has become hugely pronounced worldwide and also in India. But let me give you some data points why this might be a big concern in some developed parts of the world, but not in India, at least at this moment for next 10 years. Globally, in US, for example, more than 3 to 4% of the energy actually is getting consumed in a couple of thousands of buildings, which are data centers. So naturally, there is a concern. 4% of the electricity, the whole country getting consumed into data centers, and with AI coming in, it is threatening to become 6%, 7%, which can definitely divide the population, and the residents think that will the power be available to our homes and houses or not, or will the cost of power increase and which will get passed on to consumers. So that is why there is a hue and cry in US. In Singapore, which is a small city country, almost 8 or 9% of the power of Singapore actually got consumed into a couple of data centers, and that is why there had to be moratorium in Singapore. If we talk about India now compared to this, industry was just 200 megawatt 7-8 years back. Today we are almost 1.5 gigawatt as a data center industry. This 1.5 gigawatt in data centers compared to 550 gigawatt which India has the installed capacity of power today. So if I just see the ratio, it is 0.3%, right? 0.3% of the total installed capacity of India is being consumed by data centers. And by the way, of this installed capacity in India, almost 52% is green power. India has got one of the strongest green power index in the world. So we are not impacting climate because even the power consumed by data centers mostly, or even the power consumed in India actually is green power. Let's see the impact of AI. We all are feeling that this 1.5 gigawatt of data center capacity may become almost like 7, 8, 9 gigawatt by 2035 because it will require millions of GPUs and compute chips and thousands of data centers will have to come. We all are building it right now in India. But by that time, when India becomes, let's say, 8 gigawatt of data center capacity, the installed capacity of power in India also will become 900 gigawatt as per Ministry of Power. So even at that time, India will still be less than 1% of the total power capacity of the country. So I sometimes say the concerns of the West sometimes get imposed on India so that they have had their share of growth and they try to push it, you guys don't do growth. So in India, I think we already have enough balance. We are creating huge green energy. Our ratio of what data center consume is far lesser than what our developed worlds are doing. So yes, we should consume less power in data centers. We should consume more and more green power in data centers, but we should not be stopping our growth of data centers and AI because these concerns are not relevant in India, at least for next few years.
That's an interesting statement. Navin, would you like to chip in?
Yes, so energy, he has talked about it. There is other reason why it's a love and hate relationship is, I'll bring up 2 points, security and ethics, right? There's a lot of concern. People ask me, is your email written by AI with a concern saying, and people saying, will AI take my job? To many other things. So there is always that kind of thing happening, is that data center which is enabling AI, is that good or is that a disruptor for what we are seeing? And then being so powerful with the intelligence coming in, what kind of security threat is there? So I think it's an opportunity for us to solve it. But for now, yes, those love and hate keeps coming.
Ananda?
See, I have seen data centers or mostly HPC coming from a very love-love relationship itself. I've seen the weather forecasting being done in India from the early days. I've seen oil drilling, ONGC being able to do that. Mahindra first setting up a VR center. So I've seen those benefits from a long time. So I see that over the time, it was initially when they were also setting up, these questions were coming. But over the time, chips have become much more powerful. Performance per watt, as we call up, or teraflops per watt, as we call up, have overshaded this concern a much on the power side, which I'm seeing people like Cerebras and also others are also doing that way. I think over the time, this will overshadow that, and we will see the benefits much more.
Lakshmi?
Adding to the points of my colleagues over here regarding responsible and ethical AI, I think I don't see it as a love-hate relationship, first of all. I think all technology is meant as part of our evolution for mankind. The same at the time of the Industrial Revolution. Everyone thought people would lose their jobs, but everyone just moved up one level to learn to use machines and free up their time for more high-value work. This is expected to do the same thing, though at an even more finer and subtler level. So the problem actually is not with the technology, but how we use it. It depends on our consciousness, whether we use it for good things or bad things. It's just like nuclear energy.
That's great. That's great. Sunil, you had already set the context that, there's nothing to worry much about it, about the green impact of it. So what are the innovations that you are taking care of to ensure that you are on that trajectory, the green trajectory?
So, so as I said that on one side, if we have to serve AI, the benefits of AI to 1.4 billion people, right? Whether people are using smartphones to consume applications or AI-driven applications, or for that matter, even the people on the fringes who are using feature phones. In India, a lot of innovations are happening which are voice-based AI, so that even people with landlines and with feature phones also can speak to the device and actually get the results also in this thing. So in India, we have always a unique thing that technology has to serve the masses at 1.4 billion scale, which will always be much large. We have seen the deployment of mobiles, internet, 4G, 5G, UPI. There are enough examples where once the technology reached a tipping point, it has gone on a huge scale. AI, even if it's not today, many use cases of AI eventually will come, which will start serving the masses. And at that time, you will have to create an infrastructure of that scale. So today we are happy that we have got X amount of data centers and we got few thousands of GPUs in India. But once that scale start coming in, inferencing being done by millions and millions of people on multiple use cases, you will require a huge multiplier on this infrastructure. So that is the need of creating this infrastructure. That is the business I am in, for example. And that's where government of India and everybody is putting lots of effort to create this infrastructure. But the balancing part is, in data centers, we always do two things. How much power you are using, so you reduce the power, and what type of power you are using, right? I'm again coming on the power aspect of that. How much power, it is a ratio of, is a matter of, is the chip efficient? That possibly is for NVIDIAs and Cerebras of the world to see that their chip is efficient, consume less power for same exaflops. Or maybe software guys that their coding is efficient, their model is efficient. But what we as DC operator can do is, the power which goes into cooling of the equipment should be reduced, right? That PUE should become lesser. And that is where lots of technologies have come. In the GPU world, you must have heard of something called liquid cooling. You are taking literally a special liquid or a water right on the chip itself, so that the water extracts the heat right then and there. So you are spending less power in cooling the equipment. And there are many practices and technologies in which you are reducing the amount of power being used in the data center. The second part, and equally important part, is the type of power you're using. I would say good part is because in India, the industry started scaling much later. The data center started scaling 17, 18 onwards. So the concerns of the West were already known to us. So right from day one, everybody in the industry started adopting green to the maximum possible extent. Today, you talk any DC operator in India, at least 30 to 40% of the power they're consuming actually is green. In my case, my Mumbai campus is 80% green. My Delhi campus is 100% green. It is a combination of solar, wind, hydro, biogas. In future, once nuclear becomes commercially viable, we all, I'm sure, will start adopting nuclear as well. So essentially, as I said, we need growth, we need this infrastructure, we need millions of GPUs to run AIs, but we balance it off by making sure we consume less and less power and we consume more and more green power. That's what we are doing. Yeah.
That's great. Lakshmi, you are working in a place where you're creating something which is beyond the traditional GPUs, this next-gen AI hardware. So can you please explain that bit a lot?
Sure. Thank you for the question. At Cerebras, we do wafer-scale AI hardware, which means we don't cut the wafer into chips and create GPUs or ASICs as in the traditional sense. The entire wafer is productized as is. Because for large workloads like AI, you need massive compute. It's got 1 million cores on it. It's got petabytes per second network bandwidth. So the network is on the chip. The memory is on the chip. And that's why our inference can be 20 times faster than a traditional GPU. Now, also adding to the sustainability angle, the total cost or the power should not just be measured on the power for a single unit or a single chip. It's the cost of agentic AI. So with today's agentic workloads and use cases, the power efficiency with which you deliver the end result to the user, it includes the memory, the network, the time that is spent moving data, and everything else till the final output comes to the user. So designing efficient systems is also very much part of sustainability, which is what we do.
That's great. So physical data centers can be green only when they have the right infrastructure to support. So my next question is to Navin and Ananda. So what is the secret sauce to this? And also, how are you balancing innovation with sustainability?
So if you look at data center, we talk GPU a lot, but if you go deep inside it, GPU happened to be the first compute element which solved some of the workloads that we put in. But what is happening is we already have training versus inference. We are already talking about enterprise versus hyperscaler. So there are many different use cases, and the workloads is driving a customized compute inside the cloud or a data center. Mix of general purpose GPUs and very custom GPUs, call it XPUs, and you see the hyperscalers buildings at the end, and the percentage of that is increasing slowly that we are seeing across the data center. But that's not the only thing. We'll have to put these compute elements together on a rack, on it, like, the tray or a rack, in the aisle, on the floors, in the building, and across the continents. So they need to connect. Today, if you see that significant amount of time spent by data is when it's on network, 50% or more. Similarly, the power consumed is a lot of time, 50% of that is when the data is moving across these. When I put a prompt and then it goes and gets the data. So the networking piece is becoming very critical now. That how do we move the data faster so that when you spend this $10, $20, $40,000 on a compute cost is not sitting idle for 50% of the time because your data is moving. And hence we have started investing a lot of things in how do we move the data faster. And move the data faster, there are interconnects, there are switches, there used to be copper technology. We are moving into optics. We have started moving the optics very close to the server and connect all of this to create what we call as a scale up, which is within the same rack, and then going to scale out and scale across. And probably the discussion we were happening saying scale beyond, can we take it into the orbits and other stuff as well? So that's the overall scheme of, I would say, the infrastructure layer that needs to be put in to enable these data center for the future. And as we do it, obviously the sustainability comes in, and it's not just in the software layer. We have to start right at the hardware. I look at transistors and figure out, based on workloads, how do I customize? Based on the hardware concepts, the utilizing the physics and the electrical effects, how do I reduce the power? But then take it up to the firmware level, and then finally up to the cloud and the orchestration layer. Power is a more design constraint rather than an optimization problem to be solved.
That's great. Ananda?
Just to add to they have done it, outlined it really good. Just to add to that, sustainability is not a choice anymore. It's more of a basic design requirement. If you see the way data centers evolve, current servers, GPU has become a first-class candidate now. Maybe for 4 years back, it was good to have. Now it's a must-to-have type. The servers have become a 15 kilowatt per servers, where the entire rack used to be 15 kilowatt. Now a server is 15 kilowatt. So newer technologies, like the way he mentioned, liquid cooling type is a must requirement, where earlier it was like a good to have type. It was good to have. Newer measurements like PUE ratio is definitely there. As he mentioned, the PUE ratio was there. Newer measurement, as she mentions, we call it tokens per second per watt. How much tokens per second per watt is the your chip is able to give, and that depends upon how are you able to cool that, because it's not only about the performance is one part, but if you are not able to cool that, you can reach the TKs much earlier. If you have to have a boost clock running and make the maximum tokens out of your chip, you have to have the TKs of the chip much lower and have to cool them with liquid cooling. So fewer guys like Lenovo is working on that extensively. We have more than around 30 servers which have liquid cooling. And not only the GPU and the CPU, the memory, the drives, the networks, everything has become, the CPUs itself has become more than 500 watts nowadays, which used to be 200 watts few years earlier. So the entire design has changed. And now people are talking, as I was in Germany a few years back, I see the people are talking of carbon negative to carbon positive. Like that same water, if you see the air, the heat is not transferable. Water is transferable. So what happens, the same hot water they are using in cold countries to warm up a building. Or the same water they are using it to a swimming pool, warm up a swimming pool. From a carbon negative, we are talking of carbon positive. So the entire design itself of how you design the data center has completely changed.
Sunil, my next question is to you. So, is scaling data centers is a challenge? Is it a challenge? And what kind of regulatory support do you expect?
Again, this is a question which I think is always asked in any panel or any discussion. And we all as the industry keep on hounding the governments, both central government and state governments. Give us everything. Give us subsidies, give us discounts, give us stamp duty waivers, give us registration waivers, give us cheaper power, right? If you ask me, these are challenges, but these are not unsurmountable challenges. If they would have been challenges, would have been blocking our growth, the industry would not have become from 200 megawatt to 1.5 gigawatt just in the last 7-8 years, right? So as I say, as Indians, we know we all have challenges in our country, but as Indians, we also know how to surmount those challenges. So none of them are unsurmountable. Good part is that a big part of this data center related aspects like land, power, single window approvals, building approvals and lots of things, they are state subjects. They are not central government subjects. State governments in the last 7-8 years have realized what is the benefit of having data centers in their state. So state governments nowadays, almost like I can count almost 15 states who have got unique data center policies now. These are no more a part of some ITS policy. They are focused data center policies in which they are giving whole lot of incentives and benefits and single window clearances to the data center operators in case you come and put up data center in their states. So when you see a Google, for example, announcing a big capacity in Vizag, for example, because Mr. Naidu is giving lots of benefits. Similarly, when when Telangana, and Hyderabad was coming in, again they gave a lot of benefits. Same policies you can see in Uttar Pradesh or Gujarat or Maharashtra, to the extent of states like Madhya Pradesh, right, and Jharkhand. Even they are coming because they have very cheap powers available. Government, which I always say should rather be focusing on the supply side, land, power connection and building and all. They should rather be enabler of demand. What we all say that we guys are all in data center layer, cloud layer and GPU layer. If you add up, we are all putting billions of dollars. It's no more millions of dollars, it's like billions of dollars being invested. So when you're putting that type of investments, we have investors and banks behind us who are giving us funds. So there has to be visibility of the returns. Indian AI market is still very small. Okay, while the cloud market is matured, the general enterprise application market is matured. The AI adoption in India is still more of a POC pilot stage. It still not has gone at a very large scale. We are waiting for that stage to happen. So that is where, for example, Government of India came with something called India AI Mission, where they said we are creating a $1.2 billion fund. We will buy GPUs, for example, on a cloud model from people like us. So the Government of India pays us the money, and then they give these GPUs to startups and IITs and all other bodies to build India-specific models. So that is a great initiative where government is saying till the time private sector demand catches up, we will create an artificial demand, take up your infrastructure, make your business case feasible so that you invest into infrastructure. At the same time, we'll make sure that the models get developed, data sets get developed, applications get developed, because now startups are getting GPUs free of cost. That is how Sarvam ended up creating a model. That's how IIT Bombay ends up creating model. And of course, many Bangalore-based company, Socket, GAN, Gyani, many of them model because all of them got the subsidies. So I would say, on one side, the supply level incentives are already being given by state governments. I think it's a great environment. Whatever better they do in terms of ease of doing business is great. We still need a lot of approvals. Better they make it easier. But if Government of India and state government decide that they will totally get digitized, they will adopt cloud, they will adopt AI, and they create demand for people like us, that will be the real thing.
This brings me to the next question. So you spoke about state policies. So will metro cities steal the show, or we have equal competitions from tier 2, tier 3 cities?
Again, I think this is a question.
You have to wrap this up in 30 seconds.
Sorry?
Yeah, this is a quick thing. I'll not give you time to think.
I think it'll take time. It's not even metro cities. As of now, it's all concentration in 6 or 7 cities only. Mm-hmm. Mumbai itself is almost like 50% of the total DC market. And then you have got Chennai, a little bit of Hyderabad coming in, Delhi coming in, and all, right? Mm-hmm. But till the time we don't have some strong use cases of small edge data centers, which is like combination of 5G coupled with sensors, coupled with AI happening at the edge itself, where real-time processing has to happen at the edge, where you cannot take the signal to the central data center. Once those use cases at large production sort of a scale start coming in, the edge data centers in the tier 2, tier 3 cities, they'll be good to talk to, but they'll not be financially viable for people like us to invest into. So we are waiting for those use cases with AI and 5G combination coming in, and also the LEO satellites-based internet coming in, which will cover the whole country on high bandwidth. Possibly those use cases will come in, and then we'll see the real emergence of tier 2, tier 3 data centers.
That's great. My next question is, what should be non-negotiable in the design and governance of next generation data center in terms of infrastructure I'm talking about? So this question goes to Navin, Ananda and Lakshmi. Lakshmi, will you take it first?
Yeah. So in terms of next generation data centers, I think we should be looking at futuristic workloads, not the workloads that we see today, because things are changing so fast. And by futuristic workloads, I mean if you extrapolate, it's going to be multi-agent workflows, agents talking to each other, doing things, executing tasks and giving you a final output. So this means it is not a single prompt answer use case. It's going to be, you give it a task, it goes into a spin, writing code, testing, then self-correcting, and finally gives you an output. So it's called an agentic loop. So this kind of reasoning loops require a lot of data movement between compute and memory, if the memory is outside. In architectures like Cerebras, the memory is on the compute. So you don't have to move it, and that's why it can be so fast. Apart from this, there is also the angle of the cluster. So in the cluster, there is a lot of time that is spent in synchronizing data, the components talking to each other, in moving in the control and the data planes. So in a sense, the cluster components are actually spending more time talking to each other than thinking. It's only after thinking that they can give you a reasonable output. So to balance these, we need innovative architectures at the cluster level, orchestration from end to end, and ownership of the entire software hardware full stack. Unless we optimize from hardware till the end output, we will not own the flow if you set up the data center in India. We are only renting components and putting them together. If you own the flow and own the optimization from hardware till the end, then we own the intelligence that's being served.
Hello. As for me, as I see if you see the adoption lifecycle curve, we are going from early adopters to early majority in the AI adoption lifecycle curve. So the focus was mainly on the training side. Now with early majority, I see the focus will be more on the inference side as we move. So, and as he was mentioning, Sunil was mentioning that the edge and the concept of hybrid AI will be more relevant. For example, to give you an example, a bank will want a fraud detection to be done at the branch, not at the data center. A self-service checkout problem, a loss has to be done at the retail center there and then and there. So the focus though we have been in the last 4 years was developing models, training models, but the way it goes about, the data gravity coming in and the latency at the edge needs to be designed in a manner that, and the focus should be there, that how do we can catch the things there and there, rather than taking it to the core.
So I think building on that theme called training versus inference, the commercialization or if somebody has to say that we are spending 1 trillion capex on data center in the next coming 5-10 years, how to capitalize that kind of an investment? Inference is what will enable that, right? And that's where we are going. The big change in the data center that will happen is that there's a lot of heterogeneous imprint that will come in. Where what we thought was a traditional model of a GPU network and in some way is a very heterogeneous format that will start coming in. And especially how it will look like is that we think it's GPU, it's not actually one GPU, it's a many GPU and an XPU along with many co-processors, accelerators and all of that coming in. They're all connected and enabling these inference workload which can fit into these 50, hundreds or some of those XPUs rather than looking at million XPUs that you have there. The second one that as a foundational team that we look at it is that your data is changing every day or every week. Your models are coming out every week, every month. Your new API applications are coming out every month or often. But I take 2 years to make this semiconductor chip that goes into it. And to get into a production so that the gentleman can buy it, it is 3 years or more. So I'll have to have a forecast of saying what will he need 3 years down the line for the inference workload that would come in. And I can fit in with the right power, performance, latency, and all those requirements and be able to do that for these inference loads so that we can capitalize the money that we have been investing. So that heterogeneous integration and that forward looking of an N plus N1 and N plus 2 vision is what is driving, I would say, the innovation that's happening.
Oh, that's great. This brings me to the last leg of the conversation. So, as you said, that we already have the learnings from the West. So this is a closing question to all four of you. Is it right to say then slow and steady wins the race? India started a little late. So is slow and steady wins the race? Does it fit India's data centers journey?
Possibly right now, whosoever is most agile and fast will capture the opportunity. So maybe when you are into a steady state environment and you are witnessing organic growth on a mature technology, then slow and steady wins the race. But when you are witnessing a new revolution and you have to capture the revolution at some layer of the stack, every single person in the stack will have to really move very, very fast because the time of building that infrastructure and that foundation is now. So whether it is chip layer, whether it's the server layer, whether the cloud layer, whether the model layer or the dataset layer or the app layer, the time is now. So I disagree. I think right now, whosoever is fastest, and of course, diligent, smartest, that's a hygiene. But you have to be extremely fast right now.
Okay, so out of 10, how much would you rate India's DC industry?
India's?
DC industry, out of 10.
I would rate it almost like 8, 8.5. Okay, scale-wise, we are still too small. India need to be at least 20 times bigger compared to what we are today, at least. But everything else-wise, adoption of green power, world-class infrastructure, what you can expect in the US and all this stuff, and on every other parameter, you can find Indian data centers to be absolutely world-class. So I will rate it almost like 8.59. Yeah.
Thank you. Navin?
Yeah, so definitely it's not slow and steady. This is a fast moving, every day things are changing. It needs to be extremely fast that we need to move because the technology is still evolving. We don't know what's the use case that we have. And I think state of, I would say India DC, since I see from the silicon layer, it's probably at 2 or 2.5. We are building things based on one general purpose model that we have learned and then putting the box together. But this will evolve. How sovereign AI will come up in India and that will drive the need versus the general commercial one will drive the separate need. And that still needs to be evolved. We are not building IP, chip or any of those things. We have no OEM or DMs building that, right? So that ecosystem is hugely vacant and open for opportunity for everyone.
Please take note.
I see that as an advantage because, as you know, McKinsey came out of a report where 80% of those POCs and the pilots are not getting into production. For production AI, as I feel India being a cost-conscious country, it definitely helps us. Primarily, if they call it the revenge of the CFOs. I don't know if you have heard that term. McKinsey call it the revenge of the CFO. That if you are not able to show ROI within 18 months, we are scrapping all your pilots and productions. So that really helps us if we have that knowledge and being a cost conscious and being able to go into the production grade AI, enterprise grade, actual use cases.
You have to rate the DC industry. You have to rate the DC industry.
DC industry in terms of technology, we are, as you mentioned, we are at 8.5 to 9. In terms of use case and applications is where we are evolving, I would say, as compared to the West.
Lakshmi.
Yeah, I also don't agree that it's slow and steady. We have to be fast and furious, is my view.
Oh, fast and furious.
Yes. And I think we also need to be planning ahead and think from first principles when we set up our large-scale infrastructure. So when you're working from first principles, you don't go wrong. Even future workloads will still fit. And the third thing is the hunger for compute and the ability to stay ahead of the curve, I think would be very important. So skilling the large scale, student population or the younger workforce, I think that's going to be very important. And I would say we've really arrived. If a kid in a small town can have the same access to democratized AI as somebody, as his or her counterpart in an advanced country, only then we have arrived.